Hello, everybody. How was lunch? Awesome echo. Yeah. Okay, so I will go 2 steps backward, so might hear less echo. So, how was lunch? All right. Okay. Next subject. Next question. No. I want to start with a story. We are all web developers. Yes? Of course. And we love to develop applications on our desktop or your computer at work. And we write the code and we test it. And the code is very, very performant on our machine. And then we check it on some staging machine and we ship it to production. And we hope that the users will like us. And the user expect that this app will be very fast and fluid. And then the first user comes to our application and start using it. And the second one, and the third one. And they came from a different device than our laptop, which is a mean machine for development. And they are waiting, and waiting, and waiting up until something happens, which leads to frustration. And then they work with your app. And you wrote a very nice app, but when they move from one page to another, it's not so smooth. And the drop-down that you are so proud of it doesn't work as expected on their machine. Or even the nice toggle component that you created is quirking. So the users love those kind of things in our applications. And all we wanted to do is create the best application that we can, but we haven't considered our performance in the application. And this talk is about how to profile your application and how to find bottlenecks in order to explain to you that this is a process that you need to do while developing and not when your users are complaining. So, a few words about myself. As was presented, I'm Gil Fink. I'm sparXys CEO. I have only one employee. He is on stage. I'm both a Google Web Technology GDE, Google Developer Expert, and a Microsoft Most Valuable Professional, MVP, Microsoft MVP. That means that I have a splitted identity between 2 companies, Microsoft and Google. And sometimes my right hand is fighting my left hand. I wrote a book back then in 2014 that explains how to create single-page application, the concepts of single-page application development. It was written with backbone. Okay, so if you're doing React, Angular, anything else, it's still for you, but it's with a very old library, unfortunately to me. So what we are going to do here in the next 26 minutes. First of all, I will explain to you how browser render your web pages. And then we will delve about the process of how you profile your web applications using the Chrome developer tools. So let's start with understanding the browsers. First of all, browsers run inside devices. And each device has a refresh rate. That refresh rate is mainly 60 times a second. That means that we have 16 milliseconds for each frame to be shifted to the screen. But in reality, that's not really happening, because we get only 10 milliseconds because there is the overhead of management that the browsers takes from us. And we strive to make everything works in 16 milliseconds. No upper than that. What happens when we go more than 16 milliseconds? Junk. Not with you, but with A. The page is looking very non-performant. So how the browser works underneath? The browser has a pixel pipeline that whenever you ship a frame to the screen, the entire pipeline is running. Let's start with the first step in this pipeline, JavaScript. JavaScript is the language that we write the application. The user interacts with our application, and we are calculating, or the JavaScript calculates the visual changes that are going to be shipped. If you're talking about CSS animation, transition, and web animation API, those things happen in this part, in this step. Style. You're writing CSS. So browser figure out the CSS rules that you are writing and calculate every CSS selector and impose those styling to each and every element on your screen. This is only the calculation. Then the big parts begin. Layout. In the layout process, the browser calculates the space and the position of each and every element on the page. There is a web layout model that you probably know, the box model, and the browser will calculate everything for each and every element on the page, and this calculation is very, very long. Then, in the first step, we have the paint. A paint is the browser is going to paint all the pixels on your screen. That means that each and every color or text that you have created will be shipped to that screen. And this is also a very long process. Last but not least, composite. The composite is, you ever used Z-index? Elements can overlap other elements. Then in the composite step, the browser calculates all the overlapping and just push one element on top of the other according to your things that you created. And this is a fast step because it runs on the machine GPU. And you need to know two things about this process. The first one is reflows. What is a reflow? A reflow happens whenever you are changing something in your DOM. You resized your web page. You removed some element. You added some element. In a reflow, what the browser is going to do is context switch, move to reflow process, and run this whole 5 steps of the pixel pipeline. Okay? The second process that can happen is repaint. In repaint, you are changing something visually. For example, you change some text, or you change some visibility of an element. Once you do that, the browser understands that it's not supposed to affect anything about the layout, so it runs the entire process, but without the layout. And reflows and repaints are very painful for you because you can't control when the browser is going to do those things. So we as developers need to minimize those things, those reflows and repaints, in order to get better performance. So please understand the browser and how it works, and it will help you to understand how you can quirk your application to better performance. Of course, there is a third process that can run, which is not a reflow or repaint. That is, once you do some callback and you're not changing something visually, then only the 3 steps of JavaScript style and composite can run or will run. Suggestion from Google, Rail model, user-centric performance model that helps you to make your apps better. What is the Rail model? Response. You need to respond to each and every event under 50 milliseconds. If you do more than 50 milliseconds, the user will notice those changes. Animation should be produced or should produce each and every frame under 10 milliseconds. More than that, the pace is going to be janky. Idle. Like developers, lazy developers, we want the application to be as idle as possible. That means less job the application is doing, it is more responsive and more performant. Last but not least, there was a session about loading before me. Deliver the content under 5 seconds. More than 5 seconds, the user will hate your application and will go to another application instead of staying in your app. and that will be a shame, because we created something sophisticated for our users. So these are the thumb rules, okay? And with that, we are ready to profile. When you go to do profiling in your applications, you will probably use a developer tools. The developer tools of Chrome, this is what I'm going to show you, but there is in Firefox Firebug, and also in Edge there are good performance tuning tools. But in this topic, or in this talk, we are going to talk about Chrome DevTools. So let's go and let's move to a demo. You can see here an application. It's a simple application that draws a lot of circles on screen, and each and every circle has its own color. But, and this is the big but, there are performance problems with this web page. So if I refresh it, let's refresh it, it runs very, very fast. But this web page has a few quirks that we will try to figure out together. So first of all, I'm going to open the developer tools, F12, and I'm going to run the developer tools, or the performance tab, and I'm stopping it, and voila, I'm getting something very, very, very frightening. A timeline with a lot of information. But this information can help you to figure out what's the problem with this web page. For example, this mark here, the red mark, says that something is wrong in this part of the timeline. So I can see those things. The task took a lot of time. If I want to drill down to things that happened, I can check the bottom-up view, and in the bottom-up view, the developer tools are smart to show me that there are problems here, and the problems are indicated in the decimal to hex function. Let's jump to there. And the decimal to hex took 1.4 seconds. Why is that? It looks like a very neat function, a string. It's just string manipulation, but it takes a lot of time. The reason is that string concatenation can be very, very non-performant if you are doing those things again and again. And we have here a lot of colors or a lot of circles that we are painting. And you can see here that I'm using the decimal to hex 3 times with writing to the console, which you can see is very, very long. So please don't ship console logs to production, please. And you can see here that what I'm doing is I'm just putting the background color with this string here, which is calculating through three colors that I'm sending, the red, green, and blue. So if you think about it, this is a function that I took from the internet that calculates this thing, this decimal to hex. And it's cool. Somebody wrote that. But, and this is the big but, the problem here is I could have done it in a better way. I have red, green, and blue, which are sent to my component. And can you suggest a different solution to this line of code? So I might heard that somebody said that, but this is a different solution to the same line of code. Let's erase it. I have red, green, and blue, so why not using CSS RGB function instead of calculating everything by hand with a function? This can solve me the problem. So I'm saving the code, and I will rerun the same process here. And I will check what's going to happen. So we are looking at the bottom up, but what we can see here is the decimal to hex function ran less time than before. And this is the neat thing here. What I've done right now is I was working with you on a performance problem through a process. So let's understand what is the process that I did. First of all, I established a baseline. You haven't noticed, but I'm running in incognito browser right now. Let's move to the demo again. Sorry. This is an incognito browser. Why is that? Because I want to be in a clean browser without any extension interfering my process. Also, I can take a different branch or put a label when I start. This is the establishment of a baseline. After I'm doing that, I'm collecting data through the Performance tab. And then I analyze the data. How did I do that? Using the bottom up, for example, to see which function took more time. And once I know or analyze the data, I can try to figure out a solution to the performance bottleneck. I'll do that, and then I'll tune my app and test and measure again to see if something changed. If something changed, good, we're on the right track. If nothing changed, I will collect the data again, try to analyze it again, try to tune up the application again and again and again. And this is the process of profiling. So let's do it together in a different page. So I'm moving to a movies page here in my app, and all the app will be published online. And as you can see, I like Star Wars. I really like Star Wars. And I have here a function called change title. Once I press it, it is fast because it's on my machine and it's a mean machine. But in other computers, it is going to be very slow. So let's try to figure out what is going on here and why is this button is taking so much time. So I'm recording. I'm changing the title. It takes some time. Hopefully, it will take less than 10 minutes. Okay, it changed. And I'm stopping the profiling. And I'm getting some results. Let's go to bottom up. And we can see here that ng-do-check, yes, it's an Angular application. And the do-check took a lot of time. And all we are doing in ng-do-check here is just changing or writing to the console. So why it took 6 seconds? So in Angular, there is a concept of change detection, and the change detection, the default change detection says that if the parent is doing something or changing something, all the other components, all the child components will do the check again, whether something changed, yes or no. And this is the bottleneck here. So if I'm going to my application and I'm changing the detection strategy to on push in Angular, it will be super performant, this web page, as opposed to this current option, which is not performant as well. So again, we did the process. We are working in incognito browser, we're analyzing, we are tuning up, and then test and measure, and again and again and again. So now we know the process of profiling. Let's move on to memory leaks. What is a memory leak? A memory leak is a memory that is required by the application, was required by the application, but wasn't released to the memory pool. And later on, the memory pool is getting full of unreleased objects, and boom, the app might crash. And we can create memory leaks in JavaScript as in every other language in the world. How can we do that? First of all, accidental global variables. This is something that might happen. You put some global variables, you forget about them, and boom, they take a lot of memory from you. But this is something that can be catched by linters or just use strict, and you're fine with that. Forgotten timers and callbacks are also something that can cause memory leaks. You're setting an interval and you're not clearing that interval. So the callback is running again and again and again, you're forgetting about it, and voila, things aren't working as expected. When you work with DOM references, please clean after yourself. What I mean by that, remove event listeners, okay? If you used an event listener and you didn't remove it and you removed the DOM element, that element still is stuck in memory. Last but not least, closures. One of the big things about JavaScript is closures. Every closure that you create is a potential memory leak, because if you are not releasing the closures, which are holding some data for you, then those closures stays in memory forever. Okay, so you need to clean after yourself. So how do you detect memory leaks? So let's move again to the developer tools. In the performance tab, you have the memory switch here. And if I'm going to put this down, you can see here the blue line here is the memory. This is the memory. Right now, and the memory is stale, and in some point it's going up, and this is where a garbage collection happened. Okay, so you can monitor your application and look at the memory. Here is the same graph again, but in a more zoom way. Okay, you can see here that there was something that caused a lot of memory to usage and then garbage collection. And you can see here that the JS heap is between 100 megabytes and 113 megabytes and a lot of details. Another option is the performance monitor. So what is the performance monitor? If you don't want to run the profiler for a long time to find memory leaks, you might want to open the performance monitor, which gives you a 3 minutes gap of memory usage, and then you do the scenarios that you're doing and try to check out if something causes a memory leak, yes or no. Another option to find memory leaks is using snapshots with the memory tab. Okay, you can keep snapshots in each and every time that you are creating or running the application. You will take a snapshot, and then you can differentiate the snapshot one and the other. So this is something that you can also do. So you only need to do is press this thing here, this record, and it will take a snapshot, and later on, 5 minutes, 10 minutes later, take another snapshot, and then compare both of the snapshots. You have here this thing here. If you have more than one snapshot, you have an option to compare the snapshots. Okay? It's not here right now. So let's summarize the session. Users expect that we will create performant, fast and fluid applications. Sometimes we create those fast and fluid applications, but they run on our machines. And users don't have our monstrous machines. They have their own machine. Their devices can be a phone which has smaller GPU than you have in your computer, or a smaller CPU. And this is making a few quirks. What I'm suggesting is to add performance-tuned cycles to your development process. You saw how do you do performance cycles. You just take a snapshot or a baseline and then try to figure out, like a CSI inspector or detective, what is wrong with the performance of your app, and once you understand or tune up the application, the performance problems will be removed. There are also memory leaks which you can detect using developer tools, and we saw that also in a demo. So don't wait for your user to complain about performance problems, solve them today. Thank you.